So starting from the previous linear regression, now we are placing that was we are going to minimize. So I is so here is I. Why I am placing that is x1 or x1, that is the first example or first training feature. Here the first value will be x1, here the first value will be x2, not x2 with x exponential 2, and that will be the y value. So here that is y value. So why we are placing here 1 by 2, that is it's by convention to make the equation simpler, and that will be equal to j phi. You will tell later on what is j phi. So that is the equation for the linear regression when we are going to make a linear model. So j phi is the cost function. We are going to minimize it as in previous video I have told that we are going to minimize it. So linear regression, we are going to tell linear regression is special case of a bigger family of algorithms called generalizing your models. It means if you are going to generalize your model, you use linear regression. An algorithm called gradient descent we are going to use. So briefly I'll tell about you about the gradient descent. If someone from you did MATLAB, they are familiar with gradient descent. Now I'll try to explain few. Start with some phi, say phi is equal to 0 vector. That will be we are going to show that that is a vector. So if we have three features or phi naught, phi 1, phi 2, so that will be with initial value 0 0 0. So now what we are going to get, keep changing phi to reduce j phi. I have already told you that j phi is the cost function and we are going to minimize it. How we are going to minimize it? Keep changing phi. In other words, we are going to change the phi and reduce that function. So that is I'll try to explain a gradient descent. So that is j phi, that is phi naught, that is phi 1. I am going to draw, my drawing is not good, just to visualize it. If a person is standing here, that is shown by black, so the person wants to go down. So what he will do, he will get some step here and get some step here, here, and will reach there. So that will be target to go from that value to that value. The person, so similarly, linear regression, we start from some point and get to the minima. Another person who is standing here will get that is the deepest point. So he or she will step down from that point. So that will be the local minima. So starting from any point, we will get at the lowest point, and if the person is starting from another point, it will get with another point. So a person may ask that the different person are going to get a different minima value. So is it really counts? So I am going to briefly explain. Minimize height of the surface of j phi. So that is the surface of j phi. We are going to minimize it in the linear regression. That is the target. I have given you example of a person standing on the some mountain and going deep down. So starting from any random value of phi naught or phi 1 or all zeros does not matter. If you are going to start from here or going to start from here, it really doesn't matter along, but how it matters, it will explain in the other videos. So here it doesn't matter, you are going to start from any point. You might reach a different local minima if you start from different point. So that will be the local minima if you are start from there that point, and that will the local minima if you start from that point. So it doesn't matter where you are going to start, so you have to reach the local minima. So that was the target of the gradient descent. Next video we'll start from here. Thank you.